Hello sir, I'm Samuel Ling with matrix number AD150278 from section 4. I will now present on my individual project of computer programming on the project data of hydrostatic force on submerged curved surface. So for the introduction, the project is studying on a writing C program to solve the practical application or real-life problems that related to the fluid mechanics. Thus, the final design of the program is tend to solve the engineering problems and reduce the complexity of the solution method with different conditions. So the topic of hydraulic forces on submerged curved surface is chosen as this project title. In practical application, in such as large water dam, the retaining structure surface may be curved and be submerged under the water. The determination of the resultant hydraulic forces typically requires the integration of the pressure forces along the curved surface. So the easy way to determine the resultant forces is determine the horizontal and the vertical component separately by considering the free body diagram of the liquid block enclosed by the curved surface and the two plane surface passing through the two ends of curved surface as shown in the figure. For the problem statement, is that a long solid cylinder of radius r hinged at a point A is used as an automatic gate. When the water level reaches Hm, which is reach the bottom, the gate is opened by turning the hinge at point A. So determine the hydrostatic force acting on the cylinder with the width of the cylinder is initially at 1 meter. So lately we will compute the solution with different variables at different conditions. So for the objective of this project is to establish the outcome of the PBL, the project-oriented problem-based learning activity, to apply the knowledge of C programming on designing a problem to solve the related engineering problems, to improve the understanding of hydrostatic forces acted on the submerged curved surface with respectively practical application, to determine the relationship among the radius, water height level, area and other variables with the resultant hydrostatic forces, and to determine the resultant hydrostatic forces. So for the methodology, there are two parts. The first part is the flowchart. So the first diagram is about the flowchart of the main function. So we start it and we scan for the value of A and B. Initially, the density of water is 1000, gravity 9.81, and then the equation is E equal to square root of ES squared plus FE squared. Then we will print out the E. Then this is a return function. So when the process is scanned about on E, then we jump to the first sub function to proceed on to calculate the value of EA. So the same, we will start and scan for the value of RWA, and then the constant variable is the density, gravity, and the S. S is from the water surface to the point and hinge, and the hinge point which is point A, and then radius is start at 0.8. When it will continue looping by adding 1, and until it is less than 3, it's not more than 3. With more than 3, it will stop and go for looping the width. So width start at 1 meter. So assembly it will continue adding 1 meter, then not more than 3. And then we will calculate the area. Area is equal to the radius times the width. And then same goes for the area is also not more than 3. And then it will keep looping, and the increment is 1. So after the variable are get, then we will substitute into the horizontal function to get a horizontal force, which is equal to H equal to density times gravity times S plus R12 times A. Then we will print out the looping, the last variable of the looping, and we will return to the main function. Then we will go for the second sub function. Then we will, also the same procedure. We will scan the variable first and the constant, and then keep continue looping, and we will get the function B, which is the upward forces equal to density times gravity times height and area. Then we will get a C function with a wet forces, and then finally the vertical forces is equal to the outward forces minus the wet force. So for the sub function we will get the vertical forces, and then we will return back to the main function, and the resultant forces is calculated. So for the second part, we will see the program. So the flowchart is show about the process of the program flow. So from the flowchart, we can refer to the flowchart and produce the coding for the program. And then the coding of the program also can be converted back to the flowchart. So these two parts are related, and after that the program is run and the solution is computed. We can see that from the result, the horizontal forces is 153.82 kN, and for the vertical force is the 84.7 kN. So obviously the horizontal force is greater than the vertical force, and for the resultant force is the 175.6 kN. So in conclusion, this project is succeed as all the objectives are being achieved, and throughout the process I am able to apply the knowledge of C programming in design the program to solve the engineering problem, which is determining the hydrostatic forces, and the result successfully show the resultant hydrostatic force. And from the project study, my understanding of this topic on the practical application is augmented, and I could highlight that the relationship among the radius, water, height level, area, and other variables are with the resultant hydrostatic forces. So when the radius of the curved surface is larger, the water height level is increased, the area also increased, and the hydrostatic force needed is larger. So in short, when the surface is larger, the hydrostatic forces is larger to retaining the structure. For the recommendation of this project, I suggest that the result could attach with a comparison among the manual calculation that computed by the normal calculator and the other one that computed by the design program. This is to prove the program created is totally correct, and we could see the absolute error between the approximation and the correct absolute error. That is the difference between the approximation and the correct solution. So that's all for me. Thank you.